So what's going on inside my Raspberry Pi Pico 2 app? How did these variables evolve to this bug state? Traditional debuggers are not always the answer to understanding real-time behavior. TST Center is a new approach to analyzing near-time behavior and a step beyond my normal printf debug lines. My thanks to TrueSmart Tech for bringing this product to my attention and for sponsoring this episode. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. Please remember to subscribe and join the community. Traditional debuggers are more about point-in-time state and then stepping through behavior. I use printf statements a lot to also give me a point-in-time clue of what's going on. TST Center tries to look at things differently, to observe variables over time in a watch list like a traditional debugger, on a graph or a dashboard view, plus some more advanced features to interact with your variables too. I've done something similar to this when I used Mongoose to expose FreeRTOS's kernel statistics over web services and then to graph them on Google Charts. That was very much a single use case approach though. It was also just a little flaky on the Google Charts side. TST Center is different. It's a product tool with a generalized capability. Sure, it can still be evolved a bit, and the guys behind TrueSmart Tech are interested in feedback and responsive to giving us the best tools on the job. Let's take a look. If you like this video and it helps your learning or your projects, then why not drop me a cash tip using that super thanks button below the video or the payment link that's in the description. Thank you very much for watching. Please hit the like button and subscribe for more. When we use a traditional debugger, it's really around stepping through our application and understanding behavior. Okay, yes, we can examine variables. We can even sometimes stop on a variable's value, but really this is a behavioral analysis rather than what we get from TST Center, which is more about looking at the variable's behavior. And particularly for me, it's about looking at and visualizing variables over time. Yes, there is a nice watch list in TST, but that's very similar to what we could do in the traditional debugger, whereas to actually graph variables over time or place them on dashboards, that's new. This video is sponsored by TrueSmart Tech and TST Center, the game changer every maker needs. TST Center is a support tool to speed up your development and debug cycles by giving you near-time access to your variables, allowing you to visualize how they change on watch lists, graphs and dashboards. With TST Center, you can move away from point-in-time printf statements to visualizing applications behavior. Try out TST Center for free for a month, and just for you, use code JOHN10 to get a 10% discount on the subscription. With TST Center, there is no more useless printf statements. TST Center is the game changer every maker needs. TST Center comes really in two pieces. The center itself, which is a desktop app, which will give us capability like to be able to look at watch lists, dashboards, tables of our data, graphs and monitor output messages. And then we've got the TST library, and that's what we're going to build into our firmware, which is actually just 4 simple files. And that's what exposes the variables, allows us to send messages over to the TST Center to be visualized, and provides comms on things like USB, UART, Bluetooth and Wi-Fi. So the library itself actually you download in a zip file and it comes in this structure here. So basically it's those source C files, those 4 files there is all we really actually need to worry about. And there's a whole load of examples if you want to look at them too. Now, of those 4 files, TST variables is the one that you're going to need to modify, because that's the one that structures all of the stuff that we want to sort of glue out of our firmware application over into TST Center and for TST Center to visualize. In all of the examples I'm going to show you here and talk through, I'm going to use standard I/O over USB to communicate between TST Center and the firmware. Now, I've had some trouble trying to do some other things like trying to get this working on UART, and I ran out of time, so I've stuck to standard I/O over USB. I would like other protocols and other approaches to be working, but that's the one I've got working so far. So to get that working, actually we only have to worry about 4 functions that we're going to call. TST init to initialize the TST comms on the firmware side. TST RX, which is receiving instructions coming over from TST Center. TST TX, which is sending over any data or responses. And TST Monitor, which just positions a message or a printf or a text message that we want to appear on the TST Center's monitor screen. So let's have a look at a couple of examples of me using the TST Center and TST library and how we're going to do that. Now, I've put all of the firmware code for these up on GitHub in this repo, so you can see what I've done. Now, the first one of these is about FreeRTOS kernel metrics. So metrics like the heat space, number of tasks, etc. I'm going to try and expose those as variables over to TST Center from my firmware so we can constantly monitor them and perhaps even graph them. I will also send out some monitoring messages, the equivalent of a printf, so to send a message over which can then be seen in TST Center. Now, the project structure for this, I'm deviating a bit from the examples from the TST Center and that library that you downloaded. In their examples, they've actually copied and pasted the 4 files that came over with it into each of the examples. I don't like that very much. I like my libraries to be clearly separated from my code. So what I've done is I've put the 3 files, the TST variables.c, TST library.h and TST library.c in my lib folder. They are hard coded in there at the moment. And then I've put TST variables as port code in a port folder. So it's how I've portably adjusted this library to run from my example. And then I've got my main app actually sitting in source. Ideally, I would have loved to have made the library itself, the TST library, actually a submodule coming over from GitHub, but obviously it's delivered via zip file at the moment, so I couldn't do that. The reason I love doing that with submodules is it makes it very clear what's my code and what's other people's. So over on the repo, let's have a look at one of my experiments, and we're going to have a look at the FreeRTOS metrics experiment. Now, I want to start by looking at this TST libraries configuration here, because this is key, and this is the thing that you're going to modify every time you're using the TST library, because this states what variables we're actually exposing, and it's really this section here that we want. We've got a silly little variable 1 in here, which is just an example. I'm just going to basically keep incrementing it so that it keeps going up. But the actual variables that are more interesting are these 2 or these 4 down here, of which really these 3 are the ones that are coming from FreeRTOS. So we're going to have the amount of memory that's free on the heap, the minimum that the heap has ever got to, and the number of tasks. Actually, in this example, the number of tasks is going to be constant, but the heap's going to be going around all over the place because I'm deliberately going to keep exercising it. The rest of this file has lots of things about our device, how it's connected via serial. So we're going to call our device my device, and it's connected as serial. I'm not going to worry too much about talking through those right now. For the code here, what I've really done. So the main program itself is really just going to start up our couple of helping agents here, which are going to actually be doing the work to link in TST Center and sorting all of that out, and I'll explain that in a second. The main body of the program really is running up FreeRTOS, and it's then going through this little loop here where I'm basically just going to keep allocating memory from the heap and then freeing that memory, and this is coming from FreeRTOS's heap space. So I've got a couple of agents here. These are run to my normal agent pattern that just basically runs these up as FreeRTOS tasks. So the first one here, TST agent. So this is responsible for basically maintaining the comms with the TST Center. And if we have a look at run here, what I'm actually doing is I'm going to force this to run on the core 0. And then I'm going to set this up, and it's going to basically keep reading data and sending it back. So basically what this is doing is maintaining some comms. So it's reading any instructions that have come over from TST Center. If it's got an instruction, i.e. the recount of bytes was greater than 0, then it's actually going to send that to TST code to actually process, and there's that TST_RX function there. And that might be things like setting a variable, it might be a request to actually get a variable's value. And then the other thing in here is it's sending anything that's currently in the buffer ready to go to TST, such as variables or messages, is making sure that they get sent over using the TST text or transmit function there. And that's really all that's running in here, and we're just doing that continuously. The TST Metrics class and agent is really responsible for copying across those metrics that we're getting. So basically here what I'm doing is every few seconds, about every 100 milliseconds there, I'm going through this little tight loop here, and I'm copying across how much space is free on the heap, what's the minimum of the heap that it's ever got to, and what's the current task count, so that those variables are then available. Because this TSTV structure, that was what we had in that TST variables.header file that we set up, and it's those that TST is pulling from. So this is how we're sort of mapping it, and that's what TST Metrics is really doing. It's mapping stuff in my application to what's available to the TST domain, and therefore getting copied across to TST Center. Now every 20 times around that loop, so every 2 seconds, so we're going to do this TST monitor send. Basically we're going to send a message over, and this is going to be a message just giving us textual information about the heap and number of tasks. Same data that we've just talked about and that we're sending over as variables, but I'm just going to put it almost like it would be in a printf statement. And this is the alternative to doing printf that we use with TST Center. Because in this configuration, in this example, I've really lost my ability to use standard out for anything else. So everything has to be fitting to the TST own framework and protocol. So that's going across over there. And that's it. That really is all there is to this example. So we got these two agents, TST agent, which is just maintaining the comms, and TST metrics, which is the one that needs to be changed from application to application, because that's the sort of binding on the mapping between the application world and what's needed by TST and mentioned in those variables. So let's have a look at this running. The first thing I need to do in TST Center is actually load up that TST variables.h file, because that's giving me the configuration of exactly how my device is set up and what those variables are. And TST Center will basically just parse that TST variables file. So it's going to nuke out everything else I had in there. Now that then now means I can now open an interface. Now I'm going to have to scan to see what interfaces I've got on my computer and select the appropriate USB port. And then I can go to my watch list. And I'm going to add all the variables from that watch list. Great. So now when I connect my device, by hitting that connect button down there, it will actually connect up over a presumed serial link over my USB port and will start giving me variables. So this is my watch list, much like I'd have in a traditional debug client. But it isn't just point in time. I can actually graph things. So here I can add any of those variables from my variables file, and here I've added the heap free, so that I can actually watch as the heap is allocated and freed and see how that's actually processing. Now, the cycle that which the TST Center is asking the firmware for those variables, the cycle of which they're being updated, these two timings do interact a little bit. And so you have to think a little bit about what's going on, which is why this doesn't look like quite the smooth up and down that you would necessarily naively expect. But it's still really useful to give me a visibility on actually what is the worst case on the heap, how is it behaving, what is going on. And finally, in TST Monitor view, I can actually see a log of all of the TST Monitor send messages coming out of my application. So here, these are the equivalent of a printf, and I can see details around what the tasks are that are running on my application, and some information there around free heap space as well. Now, a while ago, I wrote a test application to just play around with the performance of an RP2350 by seeing how many times I could calculate the value of pi to 1,000 decimal places using the 2 cores, and in fact 4 worker threads or tasks running within FreeRTOS. Now this is great, and after a minute it suddenly reports and tells you what the answer is. But it's very difficult to know what's going on and see behavior in between. Now I thought TST Center was the ideal way of doing that. So the second example is 2-core RTOS. So this example is going to run on both cores, which is important and useful. This is the example I wrote a while ago, and it's using this worker task here, which is basically going to calculate the value of pi to 1,000 decimal places. And I've got another video talking about this. It uses a library which is using the Spigot algorithm in order to do those calculations. And it's trying to work out how many times you can do that in a minute. Now, what I want to do with this one is actually expose that data so I can actually see what's going on as it's building and as the number is climbing across the 2 cores. So all I'm going to expose is 2 variables in this TST variables.h, and they're going to be basically the count for core 0 and the count for core 1. And then I can do things like graph them or put them on dashboards, which is what we're going to do in a minute. So this time, basically, I'm doing TST agent in the same way I was on the last one. So we've started up TST agent. It's just going to be continuous to maintaining those comms, just like we previously did. TST Metrics this time is also doing the same thing. It's just mapping between my metrics in my app and the metrics that are going on our in the TST variables file. So there you see we're actually mapping between the variables that we've got in the count, which is held in my counter singleton class, and into those 2 variables. That's what's going on there. Now, I have had to make one change here to counter because I really want counter to also be able to report to a printf screen and to me looking at what's going on my device over Minicom, normally on a UART port. So I've allowed it to continue to a pseudo print. So instead of using standard IO, because I'm still using standard IO for TST only, I'm this time using UART 0 on GPIO 16 and 17, and I'm using it to be able to actually send out information. So where we start here and we do print start, and when we do report, we're going to go through a whole load of prints here, and all of this information is actually going to come out of standard IO, on UART 0. And it's going to do that because actually my print function here says, actually, if you've got a UART defined, and I do in this example, then it will actually just print the string straight out to the UART, and I can therefore see it. I like this because that means that I have the still have my basic console available to me, as well as having the ability to see things via the TST Center. So, you know, I've got the best of both worlds. I've already set up in TST Center this new TST variables.h file, and I've got a graph, and I've imported both the core 0 and core 1 counts, and now we can actually see that running as I connect it. We should then see it actually starting to pull the data from my Pico, and we can see actually as those two cores are racing to see how many times they can calculate the value of pi. It was quite interesting because, you know, I thought one would be behind the other, that core 1 would be slightly faster than core 0 because core 0 is doing some of the counting and some of the other work. But in actual fact, they do actually get closer and sort of even cross at times. It's quite interesting, really. Now I can also build a dashboard. So here on the dashboard screen, I'm going to drag on 2 gauges. Now I need to briefly switch back to view mode and go back to edit mode so I can get to the selections on these, and I can then select which variables I want them to be. I'm going to give them ranges that go up to about 200 so that we can see the values. Now I can also color those ranges in, so I can choose, there we go, where the low range ends as being green, where the orange or amber area ends, and where the red one ends, and I can make those both the same on both of those gauges. So then we can have one of those gauges showing me what's going on for the core 0 and one that's going on for core 1. So let's have a look at that, and we can see now as we connect and as this runs, we can see both of these nicely and smoothly going up as the 2 cores move through their count cycle. Let's just speed that up a little bit to see that a bit quicker. I've given some feedback back to TrueSmart Tech on my experience with the product. I really like it, but there are a few areas where I think it could be improved, like understanding the performance of the comms layer and being able to clear the monitoring log, for example. I can so see this tool accelerating some of my project builds, where I have multiple stats on behavior or changes in variables over time. It's critical to understand what's going on. That could be as simple as monitoring the heat space, for example. TrueSmart Tech have given us a free trial on use and then a 10% discount if you use the code John10. So go check it out now. If you like this video and it helps your learning or your projects, then why not drop me a cash tip using that super thanks button below the video or the payment link in the description. Remember, I'm saving these up to get myself all the way over to the open source conference in San Francisco, and I'd appreciate your help in getting me there, and of course I would love to meet you all there too. Thank you very much for watching. Please do like the video and please subscribe for more, and I'll see you very soon. Bye bye.